Hello all. We are starting a new playlist related to graph data structure. We will talk about what is mean by a graph data structure and how it is represented in your memory, and we'll talk about different traversals, algorithms, and more about graph data structure separately. Yeah, coming to the definition of graph, a graph is nothing but vertices and edges. If you see here A, B, C, D, E, these are called as vertices, and if you see these arrows, these are nothing but edges. So if you simplify, graph is nothing but vertices and edges. Now, all vertices are connected by edges. Yeah, if you take a real world example, Google Maps uses graph to structure the roads. Now, let's say I'm on a Delhi highway, and from Delhi road there are ways to UP, Bangalore, and UP, Bangalore, and Kashmir. Okay, now let's say this is the point where you have multiple roads. Like let's say let's consider this A as a Delhi, and from Delhi you have multiple roads. You consider B as a Bangalore and C maybe as a Chhattisgarh, right? Now you have two roads from Delhi to Bangalore, and you have another road from Delhi to Chandigarh, and from Chandigarh you might have the other roads as well. So if you see here, if you consider this road example, you represented a real world roads as a graph. So what Google Maps usually does is they use graph data structure to represent roads and the junctions present in the Google data structure. In a Google database, they represent these roads as a graph data structure, and using this it will provide us the map. Like when you travel, you navigate using Google Maps, right? So all the road details are stored as a graph data structure. This is one real world example. No, it's not just roads. Let's say you have a cell phone network, or you have a electricity department. If you consider an electricity department as well, there might be a power station, or you can consider a southern power station, A as a southern power station. From southern power station, electricity gets distributed to the multiple regions, right? So let's consider A as a southern distribution. From southern distribution, it goes to its internal regions to B, C, or from C it goes to, even like maybe from a region it goes to districts like B, C. From districts it goes to the towns like D. From towns it goes to lanes or streets. So you can even consider this electricity distribution as a graph, or even you can represent your cell phone network also as a graph, because or you can represent your Wi-Fi also. Like there can be a one main station, via from one main station our network gets distributed to multiple places. From that place, like let's say from Hyderabad it goes to districts, multiple districts, and from each districts it goes to towns, right? So there are lots of applications in real world which can be represented as a graph. Let's say you want to know the shortest time that like let's say I have a road, and I have a place A and I have a place B. There are multiple ways available. Like if you see from A to B, I can travel via like this. If you see from, like let's consider this, from A to B, I can travel like this. From like, just a straight path exists from A to B, and there can be a way from I can go to C. From C, I can go to B, and there can be another path that exists from A. I can go to D. From D, I can go to E. From E, I can go to B. Because there can be multiple paths that exist from one point to another point, and now I have to calculate the shortest time or shortest distance from A to B. So I can represent these paths as a graph, and using few algorithms I can calculate it. So we can relate a graph to a real world application, right? So this is simply like we can represent graph like using vertices and edges. Yeah. This is the definition of the graph. Coming to the kinds of graphs, there are multiple types of graphs present, but we will not discuss, will not talk about all kinds of graphs that are present. Since our course is mainly related to the data structures and algorithms, we will cover only the main types of kinds of graphs. So graphs are categorized based on the direction. Like let's say, even if you take a road example, from a point A to point B, it can be a one-way road or it can be a two-way road. So if it is a one-way road, right? So from A to B, you can go only from A to B. You can't go from B to A. So we can consider this as a directional graph. So because you can go only in a single direction, you can't go back. So based on the direction, you can categorize graphs as directed graph and undirected graph. If it's a single lane road and if you can go only from A to B, then you are representing the direction here. You can go from A to B. You can't go from B to A. See, even if you see here, you can go from B to E. You can't go from E to B. So this is known as a directed graph. So arrow represents the direction. But if you see here, there is no direction present, which means that this particular edge represents bidirectional. Either you can go from A to B or you can go from B to A. Like you see a road, right, where people go in both directions. You can consider that road as an undirected road or bidirectional road, if you say, because you can go both in both directions, right? That's why the direction using the arrow is not represented. Or you can use this as well, because since both directions you can go in both directions, you can use this as well. Like instead of not representing the direction, you can use this as well. Okay. Yeah, this is all, we can use this as well. Yeah. So based on the direction of the edges, you can categorize graphs as directed graph and undirected graph. This is one classification. And coming to the other classification, cyclic graph and acyclic graph. So if in a graph, if there exists at least one cycle, then you call that as a cyclic graph. If there is no cycle present, then you call that as a acyclic graph. If you see here, uh, I can go from A to B, from B to C, from C to A. And then this forms a cycle. If you see this particular thing, this forms a cycle, right? So this per A, B, C forms a cycle. So A, B, C forms a cycle. Here exists at least a single cycle. So that's why we call this as a cyclic graph. If you consider an acyclic graph, you don't have any cycle present. Like, do you see any cycle in this graph? No, right? So this is called an acyclic graph. So even self loops are also considered as a cycle. Self loop is nothing but you travel from B to B. This is called a self loop. So this is an acyclic. This is a cyclic graph because you have at least a single cycle. Cycle is nothing but you start from origin and you come back to origin again via some path. If there exists a path from A, let's say how you define a cycle is, if there exists a path from A via which you can reach A again, then you call that as a cycle. Now if you see, I go from A to B, I go from B to C, from C to A, I came back to A again because cycle exists here. So there can be multiple cycles present, but if you have at least a single cycle, then you name it that as a cyclic graph. And if you don't have any cycle, then you name that as a acyclic graph, like here. You don't have any cycle, right? So in directed graphs can have both cyclic as well as acyclic. Even undirected graph can have both cyclic and acyclic. Here in undirected graph, A, B, C, like this forms a cycle, this forms a cycle, this forms a cycle, and this forms a cycle. There are multiple cycles present. So you can have cyclic and acyclic in both directed as well as in the undirected graphs. And the other classification is based on the weights. Okay. Now your edges have some weights. If you see A to B edge has some weight, D to A edge has some weight, D to B edge has some weight. Here in this particular graph, you don't see any weights present here. So based on the weights of the edges, you can classify graphs as weighted graphs and unweighted graphs. So let's consider this, like let's talk about the road example again. There exists road A to B and the distance from A to B is 10 and the distance from D to B is 7 and distance from D to A is 11. So you are putting the distance as weight to that edge. So then we can consider this as a weighted graph. Maybe you don't want to put any weight on this, then you can consider as an unweighted graph. This is another classification. And even like in directed cyclic graphs also you can have weights. Even in directed acyclic graphs also you can have you will not have weights. Like even in the undirected graph, you can consider this as a subclassifications also. Now coming to one more classification, connected graph and disconnected graph. If you see here, all the vertices are connected A, B, C, D, E. But here C, D, E are connected, A, B is connected and F is connected. Let's say this is a graph. If you see, these are not connected. These are disconnected. Those are broken actually. So you call that as a disconnected graph, and if you see this graph, all are connected. You call this as a connected graph. So basically connected graph is like if you travel from one node, you will reach all other nodes via some or the other way. Like I start from A, I go to B, I go to C, I go to D, I go to E. But here if I traverse from A, I go to only B. I can't reach other points. If I traverse from C, I go to D, I go to E. If I traverse from F, I go to only F. Like if in a graph, if you start from a point, if you can reach to all points present in the graph, then you call it as a connected graph. Whereas in disconnected, if you start from a point, you can't reach all the points. Maybe you can reach only a few points, like that's a probability, right? So that is called a disconnected graph. So these are the major classifications of the graphs, but still there are other classifications as well. Those are not relevant to us, that's why I'm not speaking here. That's it, thanks. In the next video we will talk about the representation of the graph. What are the ways to represent it? Thank you.